Hello and welcome. In this video, we will review probability functions. If we have a random variable, say x, we can find its probability function, which is a mathematical function that provides probabilities for the possible outcomes of the random variable. It is typically denoted as f of x. Suppose that the possible values that the random variable x can assume are given by x sub 1, x sub 2, x sub 3, and so on, and these are arranged in some order. Let's also say that these values are assumed with probability, that is the probability that a random variable is equal to x sub k is equal to the f of x sub k. Now we can introduce the probability function, which is also referred to as probability distribution, for any possible value x, such that the probability that a random variable is equal to x is equal to f of x. You will often hear about two different types of probability functions: probability mass function and probability density function. Let's see the difference between these two. If the random variable, which we denoted here as x, is a discrete random variable, then the probability function is usually called the probability mass function or PMF. In general, a probability mass function satisfies two properties. Number one, the probability mass function is non-negative for any value of x in this sample space. It will be zero otherwise. Number two, the sum of all the probabilities of all the possible outcomes of an experiment is equal to 1. Now let's look at what probability density function is. If the random variable, which we denoted here as x, is a continuous random variable, then the probability function is called the probability density function or PDF. So the type of random variable defines whether we are dealing with probability density function or probability mass function. In general, a probability density function satisfies two properties. Number one is the same as before, that is, the probability density function is non-negative for any value of x in the sample space. It will be zero otherwise. Number two, the area under the curve is equal to 1. Note that unlike the discrete case, the probability density function is not equal to the probability of random variable equal to x. As we can see from the properties that the probability that random variable x takes on any one particular value is 0. Whereas we can find the interval probability that x lies between two different values, say a and b. Another probability function which you will often hear is the cumulative distribution function. A cumulative distribution function, or CDF, is usually denoted by capital letter F of x, and it is a function that gives the probability that the random variable x is less than or equal to the value x. For a continuous random variable, however, probability of x equal to x is equal to 0. Therefore, we have probability of x less than x is equal to f of x for the continuous case. The cumulative distribution function has three properties. Number one, f of x is non-decreasing. That is, for any two values x and y, if x is less than or equal to y, then f of x will be less than or equal to f of y. Number two, the limit to minus infinity of f of x is equal to 0, whereas the limit to positive infinity of f of x is equal to 1. Number three, f of x is continuous from the right. Cumulative distribution functions are a great tool for comparing two distributions. By comparing the CDFs of two random variables, we can see if one is more likely to be less than or equal to a specific value than the other. This helps us make decisions about whether one is more likely to have a particular property. In the next video, we will solve some example problems. Please like and share this video and don't forget to subscribe to my channel. See you all in the next video.